Okay, welcome to Memory Session 3. We left off talking about how does a stimulus become a long-term memory. We talked about selective attention being the first active behavior that we do when a stimulus catches our attention. Now, fortunately, I said not every stimulus catches our attention, or we would be experiencing stimulus overload. But the things that matter to us catch our attention. And they go into sensory storage or sensory register. It lasts only 250 milliseconds, and that is less time than it takes to snap your finger. They're usually stored visually and auditorially. Okay, if that information has meaning for us, then it goes into the second storage system, which is short-term memory. The capacity of short-term memory is about 7 items, plus or minus 2. So about 5 to 9 items can be held in short-term memory. That's not very many items. You might notice that the phone number that I'm thinking about having us memorize would be 7 items. And it's broken into 3 numbers, dash, and then 4 numbers. That is an example of chunking. So to expand the capacity of our short-term memory, we often make chunks. We use acronyms. We say FBI, CIA. Those are shorter versions of the longer words that they represent. We chunk things like actress, and that tells us the person's gender and their profession. Most of the things in short-term memory are stored acoustically, so through sound. So if I asked you to memorize a phone number and I said it's 883-2965 and you can't write it down, and I'm going to ask you in 1 minute to tell me that number, most of you would repeat 883-2965, 883-2965, and you would be listening to the sound of it in your head. Now, some of you are visual learners, so you might imagine how it looks on the keypad on your phone, 883-2965, and you would be making a visual representation of it. Some of you are really mathematically oriented, and you would say 8, 8, and then 3, and then 2, 9. I don't know what you would do, but you would say 2 minus 9 is this or whatever. I can't even do it, but that's how some of you would do it. The length of time that short-term memory lasts is less than 1 minute. So unless you rehearse the items in your short-term memory, they disappear. They go away. They dissipate. You no longer have them. But if you rehearse, and the magic number of rehearsals is 7. 7 meaningful rehearsals will allow information to get into your long-term memory. The capacity of long-term memory is infinity. It is limitless, which is pretty great because imagine if you memorize a lot of stuff and you're about 72 and your memory all of a sudden says, "Oop, I'm full. I can't learn anything new." And your doctor prescribes a new medication for you to take. You can't remember to do it. Or you meet some new person that you might like to date and they say, "Hi, my name is Joe or Debbie." You can't remember their name. That would be just terrible. That's called anterograde amnesia, by the way, and that does happen to some people that have a physical or emotional trauma that prevents them from learning things into the future. That's anterograde amnesia as opposed to retrograde amnesia, which you're more familiar with, and that's forgetting things that happened in the past. Long-term memories are considered engrams. Remember when I asked you your first grade teacher's name? You have an engram in your memory for your first grade teacher's name. Now it's interesting because you have their name and you might have an image of what they looked like. And it's just interesting to imagine how many cells is that taking in your brain? Is it floating around or is it staying in one particular spot? And how do you access that? What is the actual mechanism of storage in your memory? Most people think that it is chemical in nature in your short-term memory and physical in nature in your long-term memory, and electricity is involved in getting that chemical energy to transduce into physical energy. The other word for an actual memory that's in your long-term memory is memory trace. So either engram or memory trace. That's what we call all of the millions of memories that you've got in your long-term memory. Now here's a thing that really helps when you're a college student. You really need to know about consolidation. That is the process that takes place that makes a memory permanent in your long-term memory. So consolidation is like storing a memory in your computer where it takes a little bit for a long document to actually, be able to store. That would be consolidation. And in our case, consolidation takes 15 minutes. If you allow that full 15 minutes to take place, then you will be able to recall that information. If something interferes with this, and so interference is our second explanation for forgetting, then you may forget the information. So that determines your performance. So a stimulus goes through selective attention, sensory storage, meaning, short-term memory, rehearsal, long-term memory, consolidation, and performance. And that is how we take a stimulus and it becomes a memory. Oh, look at that. Low battery on my computer. Better plug it in. Okay, so we can end this session right here, even though it's really short, and I will pick up with the other memory diagram in just a little while. Okay, now we're going to move on to the memory diagram that I would like you all to draw. So I would suggest that listen to me talk about it one more time, and then pause the video and actually draw this diagram on a piece of paper that you're going to bring to our exam on April 23rd. And if I ask you, how does a stimulus become a memory, you're going to have all of this to look at. Plus, I'm going to ask you, how do we forget? And you'll have the 3 theories of forgetting built into this diagram. So again, same as the first diagram. There's a stimulus. We pay selective attention. These narrower bands here, the narrower columns, those are the active behaviors that we do in order to transfer information to a storage system. So we have 3 storage systems: sensory storage, short-term memory, which is also known as working memory, and long-term memory. And in between each one of the storage systems, we do an active behavior: selective attention, meaning, rehearsal, consolidation. Okay, so back to the beginning. We pay selective attention and it ends up in sensory storage, and its characteristics are it lasts less than 250 milliseconds and most of the time is stored through our eyes and through our ears. If that information has meaning for us, our next active behavior, it transfers into our short-term or working memory, where the capacity is around 7 items. We do chunking to expand the capacity of our short-term memory. Most of us have acoustic or hearing sound representations in our short-term memory, and short-term memory lasts less than a minute. So we need to rehearse that information at least 7 times, and then it goes into our long-term memory, which is infinite in capacity, and long-term memories are called engrams or memory traces. We need to allow 15 minutes worth of consolidation time once we've put something into our long-term memory so that it is permanently affixed in our brain. That'll determine whether we recall or forget, and that determines our performance. So I'm going to give you an example of how short-term memory scares us. Okay, so let's say you haven't studied a whole lot for an exam. So you arrive in the morning and you're looking at your notes and you're just cramming. You're trying to remember, okay, I need to remember this, this, and this, this, and this, and this. And you're wishing that the instructor would hurry up and pass out the test so you can get these things from your short-term memory, boom, written down. Because they're not in your long-term memory because that's not the way that you studied. And you've memorized this stuff, or you're only in your short-term memory. You're looking at the notes. Instructor says, okay, put your notes away. So you're just sitting there going, I need to remember this, this, and this, this, and this. Hurry up and pass out the test. And then instead the instructor decides to talk and remind you that the papers due, or tell you about extra credit events at the college or something like that, discuss current events. And you're like, oh no, this is lasting less than a minute and I never rehearsed it with meaning enough to keep it in my long-term memory. So I'm just rehearsing it over and over and over to myself so that I can remember it and put it down on the test. Remember, sometimes you actually make little notes in the side of the test because you're purging that information down because it's only in your short-term memory and you feel kind of desperate. Okay, so pause the video now and go ahead and copy this diagram and take your time. Okay, welcome back. I warn you about a non-clumping clicker question. So, sensory information is initially recorded in our sensory memory. This memory may be visual, which is called this, or auditory, which is called this. Which answer do you think it is? Okay, hopefully you got iconic and echoic, and you would be happy to celebrate that you just earned yourself 5 points. Okay, so now encoding, getting information into long-term memory. I have a question for you. Do you think you're a deep elaborative processor of information, or are you a shallow reiterative processor of information? Okay, so deep elaborative processors of information really deeply study and understand what they've learned, and they settle for no less than that. Shallow reiterative processors don't really fully understand, but they repeat it over and over to themselves, hoping that when a test question comes up, they'll be able to either identify the right answer or write enough at the question to fake out the instructor. Okay? So let's think about the people in your life, people that you know that deeply and elaborative. Now, elaborative means I learn it, I connect it to other things that I know about, I can give examples of it. Think about somebody like that you know, where you know they really go deep on their stuff. Like, hopefully that's your doctor, right? Now let's think about shallow reiterative processors. Maybe it's somebody that you work with that just barely knows the procedures at work at McDonald's or something, and they don't have to deeply understand everything that happens at work, like with the cash register and everything. All they have to know is how to work it, and if something goes wrong, they call the deep elaborative processor to help them figure it out. So many people try to go through college being shallow reiterative processors, not fully understanding everything, but hoping it never really matters. And some people go, I really want to learn. I want to know this stuff. I know that if I want to go to graduate school, I really need to know this stuff because there's a grown-up SAT exam called the Graduate Record Exam, the GRE, and you have to know the stuff that you learned in your classes in order to pass that to get into grad school. So remember, if you end up surprising yourself and you want to go to grad school, it will have been a problem that you only shallowly processed the information. Okay, so to our diagram, encoding. Now, some encoding is kind of automatic. There's really no conscious awareness of the effort. You kind of already know stuff that's similar to this information. So when you are exposed to it, it just kind of automatically fits in with the current, they're called schemas, that are already in your head. So let's say you're taking a sociology class And the sociology class has principles that are kind of similar to the psychology class you've already taken. So it doesn't seem very effortful to learn the sociology.